Hello and good morning everyone. Today inshallah we will go and continue with functions, properties. Today's agenda is really very busy. We have a lot to understand and to try to grab of all this. As I told you, just wait a second. Okay. According to our study plan, we will have, of course, today we will continue the composite functions and inverse functions, and also I will try to go through the limits today, inshallah. So let's go for our agenda. This is our 7th and the 8th settings. Hopefully we will be able to do all of this. We will go through function transformations, injectiveness and surjectiveness. We will define those two expressions. The inverse function when it is going to be available for us. Inverse function in R2. The composite function for all the three types of functions. Either it is a single valued function or a function in more than one variable or vector valued function. We will go through it. As I told you, composite functions in R and in R2, and hopefully I will get the chance also to enter the limits today. So I want you to focus, and inshallah everything will be fine. As I told you previously, more than once, you will find the course references, notes on Moodle, and also the recorded lectures. You will find them on YouTube. I've mentioned this message plenty of times. If you are following my lectures, you will find that each lecture, I insist on this. You have to go to Moodle, you have to log to the slides. If you have any problem, just let me know. I will try to act as fast as possible to keep you secure. And also, I'm sharing all the files. Since yesterday, one of you told me that he has a problem in accessing Moodle. This is why I shared the previous slides with you, and also shared today the previous exams for the midterms for you to be ready, inshallah. Okay, the first thing that I want to speak with you today is the difference between one-to-one, onto, and inversion. The definition of injective, bijective, and surjective in details will be discussed in the coming bunch of slides. Let me check my pen just in a second. Okay. Just in a second. Okay. Okay. As I told you, injective ensures uniqueness, surjective ensures completeness of your function, and the bijective combines both of them together, the injectiveness and the surjectiveness together, both together. I want you to remember this standard problem, or this standard example, which is mainly about the students from your class who are living in, and we are trying to find the city of origin in Portuguese. So, as you can see from this domain into this codomain or this range, you can find some of the inputs sharing the same output. And in such a case, this function, it is not injective. As I told you, that's a non-injective example. And that will make us go through this definition. The function is injective if and only if. Okay, Omar? Okay. The function is injective if and only if every horizontal line intersects the graph at most once, which means for every value in B or for every value of the output, you will find just only one value in the input. I can say also, if you have two equal values in the output, you will have two equal values corresponding in the input. You will find this definition shortly, inshallah. The horizontal line test only works for functions, real functions in one variable or single valued functions. This is going to be, you will be able to use the line or the horizontal line test in order to find if your function is one-to-one or not. If it is not single valued function, if it is vector valued function, or it is a function in several variables, Ya Omar, what to do? All I have to do, such a case, like for example, from R2 into R as an example of functions in several variables, or from R2 into R2, vector valued functions, the horizontal line test is not going to work. I will go to the definition. The definition explains, if I have two values of the output equal to each other, it means the input should be equal to each other. If this condition happens, then it is an injective function. If it does not happen, that means you don't have an injective function. بمعنى بالبلدي لو جبت القيم بتوع الدالة اوكي لقيتهم بيساووا بعض وبعدين جبت الكورسبوندنج فاليوز القيمه المناظره اللي بتدخل الدومين لقيتهم بيساووا بعض انجكتيف. طيب لو لقيت الفاليوز دي بتساوي بعضها بس الانبوت مش بيساوي بعضه في الحاله دي تبقى اتس نوت انجكتيف فانكشن. طيب اوكي let's take more examples on this. The general اتفضل.
injective يكون equals to each others ولا هيكون في الدومين numbers on domain تبقى equals
different in the codomain, in the range. So this one is one-to-one or injective functions. So it's the definition states, as we were talking together, that we say that f is one-to-one or injective if for all x1 and x2 belongs to the domain, that's the input. The result will be f of x1 and f of x2, that's the output, which implies that x1 is equal to x2. It means you will never find two input values sharing the same output. Okay? Also, it will appear from here. If you look to this graph, yes, you are right. That's a ln x, that's a y equal to ln x. If you remark the horizontal line test, since it is a one valued function or one single valued function, is just only y equal f of x, y equal ln of x. So you have a function in one variable. In this case, if you make a horizontal line in any place or in any, if you have the graph, it should cut the graph just only one point. If it cuts the graph in just only one point, then it is an injective function. There is no problem. So if you remark, that's the logarithmic function. If I did the horizontal line just in any way, it will cut the curve in just only one point. In this case, it is a one-to-one function. Once more, if in analytic, if the domains are positive, the logarithmic function, the domain is positive, it is R positive, starting from 0, open, up to infinity. The domain I'm talking about the x-axis. And the result, as I told you, if you have f of x1 equal f of x2, it will lead to ln x1 equal to ln x2, which means x1 is equal to x2, which means it's an injective function. Of course, this is not going to be the case in all times. Let's see this problem. If I have y equal to f of x equal to x squared, that's an example or another example of one valued function, f of x equal x squared. If you remark, if I have for 1 and the negative 1, if I inserted instead of x positive 1, the result will be positive 1. And if I inserted negative 1, the result also will be positive 1. That's two different values for the input sharing the same value at the output. This is why it's not injective. So if you look to the graph, this is y equal to x squared. صح؟ طيب تعال نعمل horizontal line test. اعمل line بإيدك. بص it will cut the curve in more than one point. So it is not an injective function, it is non-injective. So it's an example for non-injective functions. Also, I have added this slide which contains the detail in definition and the principles of the one-to-one functions. A function from mapping from A into B is injective if each element of B is mapped by at most one element in A. Which means you don't have two values in A having the same value in B. Okay, That means also once more, f of A1 equal f of A2, it will imply that A1 is equal to A2. You can't find those guys equal to each other, but those guys not equal to each other. If you find those guys not equal to each other, it's not going to be an injective function. So no two errors from A can point to the same element in B. If you look to this graph or to this sketch, you will find that each value from the domain had just only one value in the corresponding codomain, or what's called the range. But it is not a necessary condition, or it's not an obligatory condition to have all the codomain elements or actually have co-images or have pre-images. So you can have for every input and output different than each other, but not the whole codomain is covered in the range. So in this case, this function is called, as I told you, this function is called an injective function. In linear transformation, if you remember, in the linear algebra, we usually knew the injective functions by getting the kernel, ya Omar, if you remember, and defining that the kernel is equal to 0. So that's the definition in linear transformation, and as we know, functions are linear transformations. So it's T such that V into W is injective if the kernel of your function is equal to the origin, which means T has among zero vectors married to 0 in value. By f of x equal to 2x, of course it's an injective function. Why it is, of course it's an injective function? Because you are talking about singly valued function. This is y equal to 2x. So this is the main function, y is equal to 2x. And if you remark, at any point, if I make a horizontal line, it will cut your graph in just only one point. So it is a perfect example for injective functions. If I have, because you will see this shortly, y is equal to x squared, as I was explaining in the previous lecture, in the previous slide, I'm sorry. This is y equal to x squared. If you make a horizontal line, it will cut the curve in more than one point. So you have various values sharing the same output. Okay? You can find at 2 and the negative 2, and they are having the same input. This is why it is not a one-to-one function, or it is a non-injective function. So once more, as I told you, that's a very good example. So for non-injective examples, f of x equal to x squared, and exactly, if you substitute instead of x by negative 2, it will give you 4. If you substitute in x by 2, it will give you also 4. This is why it's not injective. Okay, very good. This is also another example for this function if the range cover the codomain or not. If I look exactly to this problem or this example, you will find that it is not surjective. Surjectiveness means f is onto or surjective if its range coincides with its codomain. If its range coincides with its codomain, it means that the codomain or the range, they are equal to each other. It means there is no open values that doesn't have a pre-value in the main domain. So all the outputs have numbers in the input or have a pre-function values in the input. Once more, surjective or onto, a function from A to B is surjective if for every element of B, it has at least one pre-image in A. There is no elements in B that don't have pre-images in A. The codomain is completely covered by the image. For all B, there exists at least one A such that f of A is equal to A. Every element in B had at least one arrow pointing to it. I might have extra elements. Okay? So what's that mean? It means the codomain is completely covered by the main domain. But you may have some elements here in the input that doesn't have an images in the codomain. Once more, in the linear algebra, we actually used to check if the image spans all the entire codomain. If the image after transformation covers or spans the whole codomain. If it fails, it's not going to be surjective. If it covers it, so we will be, or span it, we will be in the case. As I told you, bottom line, for you to make your life easier, always remember that surjective functions, the range coincide with its codomain. So they are covered, all together are covered. Okay? This is really very good. Okay, let's continue. For example, f of x equal to 2x. This is also an example of a surjective function because all the codomain is covered by the predomain. If you remember, Omar, for f of x equal to 2 of x, that's the function that we are talking about, and for every value of y, you will find a corresponding values in x. There is no points that doesn't have a pre-image, as I told you. Or the range of the function, is covering the whole codomain. Both of them are and equal to each other. It's a beautiful example. If you look, okay, to this problem, f of x and y equal x, which means, ya Omar, it's a function from R2 into R, talking about all the elements in x and y. But the image is just only the x-axis. It means if I have a point 3 and 4, the image will be 3. If I have an image negative 3 and 4, the image will be negative 3. There is no appearance for the y value. So all the plan, after using this function, will be represented on the x-axis only. So not the codomain covered, just only the x-axis is covered. And this is why it's not a surjective. As I told you, f of xy is equal to x. From R2 into R, the second component y is ignored. You can't find y. Do you find y in here in the output? No, you can't find y. This is why it's ignored. Okay? Okay. Also, another example to be sure that you understand what I mean. If you look for y equal to x to the power of 2. If you look to y equal x to the power of 2, that's the shape of your function. Am I right? That's a parabola, that's the shape. Let's look to the range. The range of this function, it is starting from 0, look to the y-axis. This is the range. From 0 up to positive infinity. Am I right?
Yeah.
But what about the negative values in the codomain? They don't appear. This is why this function is not surjective. So, for y equal to x squared, it's not a surjective function. Okay? Okay, very good. That's the definition of surjectiveness and injectiveness. Or for functions to be one-to-one or to be onto. Sorry. Okay, onto surjective functions once more. Okay, I will give you this statement. It's the statement in the main slides. So f such that the domain from f into the codomain of f, we see that f is onto or surjective if its range coincides with its codomain, exactly as we said. And it means for every y belongs to the codomain of f, there exists x belongs to the domain of f, which means f of x equal the y. Okay, that's an example, a very nice example for surjective functions. Let's look to the output, the range of len. If you look to the range of the len function, you will find that all the y-axis is covered. Okay, so the range is from negative infinity up to positive infinity, which means the range covers the codomain. For this function, the domain is from R positive into R, that's the range. And so f of x equal to len of x, it's a surjective function because the codomain is completely covered. So this is a surjective function since the range and the codomain are coinciding with each other. While if you look to this one, which is y equal to x squared, it's not going to be surjective. Simply because after you do your from real to real, f of x is equal to, or y is equal to x squared, you will find the range for R0 up to infinity. So it's the positive part. What about the negative part? You can't find it. So once more, this is not surjective. This is not a surjective function, since the range is R positive, including 0, and not the codomain, which is R. If I want to restrict this function to be surjective, okay, I can do that by restricting the codomain. So I will restrict the range to be R positive. In this case, I'm talking just only about the half of it, the right wing. And also, if I did this, it will be injective and surjective for this function. So, as I told you, now R is completely covered for the range, so y is equal to x squared, it is surjective, no problem in this. In this figure, you can find the differences between surjectiveness, injectiveness, and the bijectiveness. In surjectiveness, you can find all the codomain is covered. This is first. All the codomain is covered. Also, Omar, you may find some of the values in y having different values in x. It's okay. But it is a surjective function since the codomain is completely covered by the range. If I look to the injectiveness, you will find that all the main domain is covered, so it has images, but there is no condition for the covering that the range will cover the codomain. But in the case of bijectiveness, you will have every element from x has just only one element in y and vice versa, as you can see. So it's exactly like y equal to len of x. It's a very good example. As you can see, for each value of x, there is just only one value of y, and for every value of y, there is just only one value of x. So it is a bijective example. That's for them. Bijective, as I told you, it's exactly how each element of B is mapped into exactly one element of A. There are no leftovers, which means surjectiveness. Those are the two conditions for bijectiveness. F of A is equal to F of AT, that means they are both equal to each other. And also B, any B will have an A belongs to the domain. There is no leftovers in both the in-domain and the codomain, they are all covered. Every element of A is paired with exactly one element of B. In the linear transformation, if you remember, a bijective means the kernel is equal to 0 and the image is covering or spanning the codomain. Okay, that's a linear element. Of course, f of x is equal to 2x, it's a bijective. This means T is an isomorphism. Also, you can hear this expression. Isomorphism. What's the meaning of isomorphism? Implying that V and W have the same dimension and they are inversions for each other, they are bijective. Okay? Okay, concept and examples in R2 and in R. Here I've thought to give you more than one example explaining the cases on functions. So for a function, single variable function, like f of x is equal to e to the power of x. Is it injective? Is this function injective? It's very simple. I can graph it. For this function, or for y equal to e to the power of x, this is, yes, it is the standard graph, which is like this. This is y is equal to e to the power of x. Is it injective? From the graph. From the graph. Is it injective? Yes, it is injective. Yes, it is injective. Because if you make a horizontal line, it will cut the graph in just only one point. Am I right? Yes. Okay. Is it surjective? Is it surjective? Is the range of this function cover the whole codomain? No. ليه بقى؟ لأن الرينج، بص يا عمر، الرينج هو الفاليوز اوف y in front of this graph. بص شوف فين الفاليوز اوف y اهي. شايف دي فاليوز البوينت دي بتديك y، البوينت دي بتديك y. These are the values of y. شايف يا عمور؟ دي كلها values of y، صح كده؟ بس الكودومين كله ده y axis اللي هو r. يبقى actually they are not equal to each other. لأن الجراف كله قدام r بوزيتيف، يعني كل الرينج هنا الرينج هو عبارة عن r بوزيتيف والزيرو انت مش هتلمسه هو ار بوزيتيف. طيب which is not equal to the codomain. The codomain is R. يبقى إذا in this case it is injective but it is not subjective. So if I want to do this, it's really very simple. All I have to do is to, as I told you, is to check that for e to the power of x1 equal to e to the power of x2, that's two different points. You have, when the bases are equal, the powers are going to be equal. So x1 is equal to x2. So this case implies, or it's a sufficient condition to have x1 equal to x2. Okay. Once it is proved, so it is an injective function. Okay, for the surjectiveness, as I told you, that's the graph of e bar x. Only the range is from 0 open up to infinity, or r positive. It's not equal to the codomain, that's the horizontal line test. I've tried to show it to you. For the surjectiveness, ranges from 0 up to infinity. It's not r, so it's not a surjective problem. But what about x cubed minus x? X cubed minus x. If I want to graph this function, this is gonna be, first of all, for this function, it's covering the y-axis from negative infinity up to positive infinity. How to be sure about this? It's the sense Omar in substitutions. If I inserted x for a very large positive value, the result will be positive. Okay. If I inserted x with a very tiny negative value, the result will be negative. This is why I'm using the limit. If x tends to infinity, this value will tend to infinity. If x tends to negative infinity, this value, because of the existence of x cubed, will tend to negative infinity, which means from these two definitions, my boy, is the whole codomain is covered by the range, which means it's subjective. But is it injective? I'm not really sure. So if I draw this graph, this is going to be the shape of this function. Look, this is going to be the shape. It will cut the x-axis, then getting a minimum point, then conflection, then a maximum, then going down. If you try to do the horizontal line test, here it will cut the graph in one point. In one point. But what if your line is here? It will cut the graph in more than one point. And if it was here, in this case, it also will cut the graph in more than one point, so it is not injective. You can restrict the domain in order to have an injectiveness, but in general, it's not an injective function, as you can see. Omar, any questions?
No.
Okay. حلو جدا. يبقى إذا الدومين, as I told you, it is injective. No, since it's certain values, there is certain values in y you will cut in more than one point, as you can see. That's the graph, and that's the horizontal line cutting in more than one point, as you can see. Okay, for y equal to x cubed, is it injective? Is it subjective? If I look to y equal to x cubed, I will discover the following. I will discover that's the shape of y equal to x cubed. And if you make a horizontal line at any point, it will cut the graph just only one point, which means it's an injective function. Also, the codomain is covered by the range. They are equal to each other. So in this case, it is injective and adjective. If I look to this example, I want to move from single-valued functions into functions in several variables or vector-valued functions, like this example or this bunch of examples that you will see. In this problem, a specific problem, you will see that an application of from R2 into R2. Since this is not R, I'm talking about vector-valued functions. If this is from R2 into R bus, so I'm talking about the function in several variables. So now, injective but not surjective, f of xy equal to e to the power of x and y. This function is injective, and this function injective. Let's check. The check is very, very simple. If you want me to go through it quickly, all I have to do Let's get f at x1, y1. And let's get f at x2, y2. f of x1, y1, it will be e to the power of x1 and y1. f of x2 will be e x2 and y2. If these two guys equal to each other, what's going to be the result? The result will be the first two of them, e x1 will equal to e x2. Am I right? When bases are equal, then the powers are equal. صح? Okay, same صديق. y1 is equal to y2. That means from x1 equal to x2, y1 equal to y2, the 2 points are equal to each other. So it's an injective function.
Okay.
Now I am following the definition because I can't find a horizontal line to draw in this case. It's a multi-variable function or a vector variable function. Are you with me, Omar? So in such case, as I told you, I made the check. Oh, this is point number 1. This is point number 2. I will discover that x1 is equal to x2 and y1 is equal to y2. And in this case, it is injective. Okay, is it surjective? How to know? Look to the two coordinates. It's an e to the power of x and y. The y is covered by the complete y-axis from negative infinity to positive infinity. But e of x, you already know that the outputs at e to the power of x just only are positive. صح? So points like negative 3 and 5, is it possible to have them in here? Is it possible to have negative 2 and 6?
No.
Is it, you can find the 6, the 5, but you can't find a negative value. This is why it is not surjective. So for this particular example, as you can see, the for surjective test, remarking that first component is always positive, e of x is always positive. Points like negative 3 and 5, you can't find them, so you can't reach them. It is not possible to have these points, as you can see. Okay, that's some more examples on the same issue, which also a very good example for vector valued functions. As you can see, the input is x and y, and the output is f of x1, f of x2. Okay, remarking that for this function, it is not injective. Okay, why it's not injective? بص كده يا عمر, this is x squared and y squared. If you use 1 and 1 and negative 1 and 1, you will find them having the same result. So that's, you have 2 points different than each other, while the output is equal to each other. Do you understand what I'm saying? So this is why it is not injective. I wrote this for you. If you have f of x and y, f of negative x and negative y. Let's make a substitution for x and y. This is the shape. Let's use negative x and negative y. What's going on? Negative x to the power of 2, x squared. Negative y to the power of 2, y squared. So it's still the same. Negative x times negative y, it will be positive x and y. So add this, it means not injective. Like, is it surjective? Does it cover? Okay, I will need to do a check. For surjectiveness, remark. Hence, this function, it contains r squared. What is the difference between x squared and y squared that's appearing in front of you? Which means you may have negative values and you may have positive values. Also for this side, you may have negative and positive values, which means the whole codomain is covered by the range. So it's a surjective function. If I look to this guy, so for the first function, it's not injective, but surjective. If I look to this case for a vector valued function, remark يا عمر in x plus y, it's a linear equation. Or it's a linear expression. It's an expression for a straight line, okay? X plus y. And the x minus y is also a description for a straight line. Both of them are completely covered, injective and surjective. So it's an example of a function bijective one, which has x plus y, x minus y, both of them are injective and bijective. That means for the first function and for the second function. Therefore it's a bijective function. If I have the function x squared and y squared, this function is not going to be injective or nor surjective. So this guy is not bijective, is not even surjective or subjective or injective also. Okay, so it fails both tests. If you try to exert to find x, y, and the negative x and y and the anchor substitution, the result will be the same. That's a failure in the injectiveness. And also, you can't find for those two values negative values. So the whole codomain is not covered by the range. If I have a function which is bijective, it means subjective and injective, I can do the inversion. I can find the inverse of this function. And now this grabs me to something really very important. Not all the functions is invertible. Just only a few of the general functions can be inverted. Okay, once more, not all the functions can be inverted. Just only part of them. Okay, so if A led to B, a bijective function, there is a function f minus 1 that will move back from B into A. And this is also one of the good things in linear transformation. We didn't do that in linear algebra. We made a linear transformation moving from vector space into another vector space. Just only few of these linear transformations were invertible. Okay. So once more, f of A is equal to B. This is a sufficient and necessary condition for f minus 1b to equal to A. Here is why. That's the reason for it has to be injective and it has to be subjective. It has to be injective because of this reality. If f must be injective so that f minus 1v has a unique image of A. If this condition it doesn't exist, so for certain values like y equal to x power 4, if y is equal to 4, what's going to be the inversion? X equal to 2 or x equal to negative 2? You will be confused. This is why if you restrict the domain for y equal to x squared, you will be able to get an inverse function. But if you left it as it is, it's not injective, it's not invertible. Also for the subjectiveness, f must be subjective, ليه must be subjective? لأنه for f minus 1b is defined for all